Hello students, the purpose of this video is to help you review the concepts of X-Intercept and Y-Intercept. So these are in previous videos, so I'm going to move a little quickly because this is a review. But we talked about the coordinates of an X-Intercept always being a number and 0, and then the coordinates of a Y-Intercept always being 0 and a number. So if I give you a problem, and it doesn't matter what format it is in, so I'm going to give you something in standard form like this. I'm going to solve two algebraic problems in order to find the X-intercept and then the Y-intercept. So again, for every X-intercept, because it's the point that crosses the X-axis, I know that the Y value is 0. So I'm going to rewrite my equation replacing Y with 0. And that gets me 2x plus 0 equals 4, which is just 2x equals 4. And that gets me x equals 2. Okay? For our y-intercept, because it is the point that crosses the y-axis, I always know the x value is equal to 0. So I'm going to replace x with 0, and then I'm going to solve. And again, if this doesn't feel very familiar to you, you're welcome to go in previous videos where I move a little slower and explain the exact algebra that I'm completing here. But that gets us y equals 4/3. So that's one thing we want to feel comfortable with when working with equations of lines. Another thing we want to feel comfortable being able to do is if I give you two coordinates such as -3, 7 and 4, 1, and let's say I ask you to locate its slope or find its slope value. I'm basically just asking you to find the steepness of the line or find its rate of change. So I'm going to use my formula y2 minus y1 over x2 minus x1, and I'm going to plug in the respective values. So I'm going to go ahead and label x1, y1, x2, y2. And plug those values in. That's 1 minus 7 over 4 minus -3. Notice that that negative doesn't represent the minus sign. So I have -6 on top, and I get +7 on bottom. So I have a slope of -6 over 7. So the next thing that we want to be able to do is to find the equation of a line. Y equals mx plus b. Well, we just found our slope is -6 over 7. And at this point, we don't know what our y-intercept value is, and we need that in order to write the equation of a line. So instead, I'm going to plug in an x and plug in a y value. And the way that I'm going to do that is I'm going to choose one of the original coordinates. It does not matter which one you choose. It's completely up to you which one you want to utilize. So I'm going to use 4, 1, and so 4 represents the x value and 1 represents the y value. And now I'm just going to go and solve. So that gets me -24 over 7 plus b, and I'm going to move that on over, and I have 31 over 7 equals b. So now I can use that information to write the equation y equals my slope that we found earlier, x, plus the y-intercept value that we just found. And now we have the equation of our line. Now that we have that equation, we can go and look for our x-intercepts as well as our y-intercept. So keep in mind, for x-intercept, I know that the y value is always equal to 0. So I have 0 equals -6 over 7x plus 31 over 7. Now I'm going to move 6 over 7x to the other side so that it becomes positive. All right, and then I'm going to divide out, and that gets me x equals 31 over 6. And I know some of you may not like fractions a whole lot. Not a big deal. You can use your calculator. Any calculator is okay. The key to remember is to make sure that you are putting every single individual fraction in its own set of parentheses. If you fail to put your fractions in parentheses in your calculator, you will get the wrong answer. So those parentheses are really, really important. For the y-intercept, I know that the x value is always 0. So I'm going to go ahead and replace x with 0. And I'm going to solve, and that gets me 31 over 7. Alrighty? Perfect. So you have now found the slope, the equation of a line, as well as the x and y intercepts. The very last thing I want to talk about is revolving more around section 2.4, where we learned about scatter plots. And if you look at scatter plots, there's lots of different things that can occur on a graph. But essentially you're taking data and you're plotting it, and you're trying to see, you know, what shape does it feel like it has formed. And the way we determine that is we draw something called a line of best fit. And the idea of the line of best fit is we're trying to see, can we draw a line that most accurately hits the majority of the data, or that at least represents the majority of the data. Sometimes we can hit every line. If we do, that's called having a perfect correlation. Correlation just talks about the relationship between the points, but then that doesn't always happen. Sometimes our line of best fit won't accurately hit everything, and that's okay. It might hit some stuff, or at least have a clear slope, and then we can talk about the type of relationship that exists. So looking at this first graph, if I were to draw a line of best fit, and just by my eye, it would be something like that. Because it's positive, that lets me know that these have a positive correlation. The second graph, there really isn't any pattern. Like if I draw a line that way, it looks just as good as if I draw a line that way. There's really nothing going on that's special here. So that means there is no correlation. On this third graph, I would draw my line of best fit around right there, and because that is a negative slope, there's a negative correlation. And although the last graph is a nice pretty shape, again, there's no way for me to draw my line in a really nice way, so that correlation would also be none. So let's make sure we remember what the difference is between a positive and negative correlation. A positive correlation says there is a similar relationship. As one thing increases, so does the other thing. So the number of swimming pools that are sold will increase as the temperature outside increases. Both things are going up. There's a relationship that's positive. It can also be a negative correlate. You can have values that are negative, values that are getting smaller, and as long as both things are getting smaller, that would represent a positive correlation as well. So, trying to think, the number of as the number of burgers that I eat decreases, I assume that my weight will decrease as well. That's a positive correlation because both things are declining. Okay. A negative correlation would be as one thing increases, the other decreases. So work with me on this one, but maybe the number of hours that I work out, I assume that the more I work out, the number of pounds that I weigh is going to be smaller, right? I'm expecting to lose weight. So the more I work out, one thing is growing, the other thing is falling, okay? Alrighty, I hope you feel that that helped you prepare a little bit more with sections 2.1 and 2.4. I encourage you to continually review material like this for your tests, and I hope you all have a wonderful rest of your day.